This video will present solutions to the 2018 VCE Mathematical Methods Written Examination 2, Section A, questions 16 to 20. Question 16. To answer this question, we require both the exact area under the curve as well as Jamie's approximation. The exact area on the curve, which can be found as the definite integral from 0 to pi on 2 of 2 cos 2x plus 3, can be calculated on our class pad. Jamie's approximation can be found by summing the areas of the three shaded rectangles. These areas will be pi on 6, the width multiplied by the heights of each rectangle. The first rectangle has height of 2 multiplied by the cosine of pi on 3, which is equal to a half plus 3. The height of the second rectangle will be 2 multiplied by the cosine of 2 pi on 3, which is equal to minus a half plus 3. And the height of the third rectangle is 2 multiplied by the cosine of pi, which is minus 1 plus 3. This is equal to pi on 6 multiplied by 4 plus 2 plus 1, or 7 pi on 6. The approximation as a fraction of the exact area will be equal to 7 pi on 6 over 3 pi on 2, which is equal to 7 pi on 6 multiplied by 2 on 3 pi. It can be simplified down to 7 over 9. Hence our answer is B. Question 17. The turning point of the parabola can be found using the property x equals minus b on 2a, or in this case, minus 2b over 2, which equals b. And the y-coordinate will be equal to b squared take 2b squared plus 1, or minus b squared plus 1. An expression for the distance between this point and the origin can be generated using the distance formula. b minus 0 squared, or b squared, plus the y-coordinate minus 0 squared. And this expression can be minimized to find the closest point to the origin using the fmin command on our class pad. Giving us the value required, plus or minus root 2 over 2, which is equivalent to plus or minus 1 over root 2, being the answer C. Question 18. The functions f and g are power functions. As such, they might be something like this: x squared and x to the half, or something equivalent, intersecting at the point 1. Alternatively, there could be two functions like x squared and x cubed, which will also intersect at 1. Or finally, it might be something like x to the half and x to the 1/3, and they will also intersect when x equals 1. Looking at those three options, in the first case, parallel tangents are possible. Hence, it is possible that D can be true, or not false. However, looking at option E, past the point 1, no parallel tangents are possible, and hence E must be false. Additionally, if you look at the information g of x greater than f of x, for x greater than 1, this means the exponent of g must be larger, and hence p over q, the exponent of f, must be smaller than m over n. By cross multiplying, this looks like np is less than mq. Looking at that expression, we can see that C is true, and by considering A and B, we can see that they may be true, in other words, are not false, which confirms that E is the only answer which must be false. Question 19. Looking at the graph, I'm going to label the bold function f as C for cos, and the non-bold function g as S for sine. Using that abbreviation, an expression for the area will be equal to Looking now at our answers, skimming through, it appears that C is the first candidate which is close to our expression, and in fact it has the same integral to describe the first area. Looking at the second term, we notice that it is double the area from a third to 1. Looking back at our curves, we can see that this area is equal to this area due to the point symmetry of the two curves either side of their inflection point at x equals 1, and hence doubling an area is an appropriate calculation to make. Looking a little more closely, we see that there is a negative sign at the front of this term. This negative sign corresponds to the fact that the cosine and sine terms within the definite integral are in fact reversed when compared to the sine and cosine terms that are used in our expression. And hence the negative takes care of the reversal of components, and the doubling takes care of the symmetry of the curve, and hence this middle term represents the two integrals in the middle of our expression. Looking at the fourth term, once again we see something very close to the integral that we have, with a negative sign, but cosine and sine reversed within the integral. And so this corresponds to our fourth integral. And so we have our answer C. Question 20. This question concerns probability density functions, and hence we know that the area under the probability density function must be equal to 1. And this will be true for the function both before and after the transformation. We are told that the median occurs at 0, both before the probability density function is transformed and after. And that means we're thinking about something like this. For our graph of f, area of a half before and area of a half after the value x equals 0 being the median. As this is going to be true after the transformation occurs also, and hence we are looking for a reflection about the line x equals 0. So we're thinking about something a little bit like -1, 0, 0, 1, which will perform that reflection. And now we're thinking about answers A or D, as they will perform this reflection. Looking further at the question, we see that f dash of 0 equals 4, which after transformation becomes g dash of 0 equals minus 1. A transformation that would have this result would be to shrink in y and stretch in x, and therefore our answer will be A, as the transformation in D will do the opposite.